Hello friends, welcome to the new session on projection of pyramids. Now this will be the session 7, and in fact this will be the last session on projection of pyramids, and the new sessions will be on projection of prisms. Now we'll start with session 7, which is on projection of pyramids. Now we touch upon problem 16. This says a hexagonal pyramid, sides 25 and height 50 as one of its slant edges on HP. Draw projections of this hexagonal pyramid when the axis is inclined at 45 degrees to VP. Assume base is nearer to the observer and show clearly the construction involved. Now see here, when they say draw projections of the hexagonal when the axis is inclined at 45 degrees to VP means, you know very well, you have to undergo beta construction. I'll explain this in this problem clearly. Now you see here, the problem is this, sir. The problem says hexagonal pyramid of size 25. You do it the same way. Side A, B, C, D, E, F, A, 6 edges. OA, OB, OC, OD, OE, OF, 6 edges. Totally 12 edges. And here you have the base 6 edges. 1 here, 2 here, 2 here, 1 here. In that way, 12 edges. Okay. It is same as previous. And even in this problem, they say clearly it is resting on one of its slant edges on HP like the previous problem. Even previous problem also, the problem was hexagonal pyramid has one of its slant edges on HP. Even here, it is up till here it is same. Slant edge on HP, for which I'll draw the outer boundary. Since base is nearer, darken the base. Since OA was nearer, OA I'll darken it. And OE, OD and OC and OD, OE, OC I'll make it dark dotted. That OD dark dotted, that invisible edge can be shown only between A and D. Till now it is same. What you have to observe here is, in this problem, they say axis is inclined at 45 degrees to VP. Axis is over 1, but it is not in true length. Okay, but the requirement is true length of the axis should be inclined at 45 degrees to VP, but true length of the axis is not found here, but it is found here, that is 50 mm. But this will be much lesser than that. Okay, now what you do is, what you do here is, you know that the top view of the axis is only 45, but true length of the axis is 50. But the problem says the true length of the axis is inclined at 45 degrees to VP. That is why draw a line at 45 degrees and cut O1 OX equal to true length, that is 50. Cut here. Once you cut here, you get the locus here. Then take 45 mm, okay, the top view of the axis, you cut here. From O1, you cut that. Okay, once you cut O1 O equal to 45 mm, you will get beta. Now what you have to do is, the second stage top view what you got, you move, copy and paste here and rotate in such a way that O1 is inclined at beta to XY line or beta to VP. You see here, once you get beta, this construction if you show, draw a line, one parallel line to this, it will be beta, then you place it here. That means you should know clearly this O1 O should be inclined at beta to VP or XY line, but not 45 degree, because they clearly said it is axis which is inclined at 45 degrees to VP, not the top view of the axis which is inclined at 45 degrees to VP. Okay, this you have to take care. Okay, now once you do this, the procedure remains set. You take the projectors up, and as usual, as I've said in the earlier problems, join the outer boundary of these points. Okay, once you join the outer boundary of these points, now the step 1 is completed. In the step 2, compare base apex with the base. Since base is nearer, immediately darken the base. Base can be seen by the observer. Okay, then base is seen by the observer. Since base is nearer, darken the base. In that way, now you complete 6 plus 2, 8 edges. And as you know, in hexagonal pyramid, there are 12 edges which have to be accounted properly. And some of the edges will be visible, some of the edges will be invisible. Which are the edges visible, which are the edges invisible have to be shown properly. Now, you are left with 4 more edges. One is OC, OE, OF and OA. Okay. You see OC. This is the nearest corner. This nearer corner edge can always be seen by the observer. Hence, you darken O dash C dash. Okay. Then O dash E dash, O dash F dash and O dash A dash all comparatively, if you see here, EFA, when you are looking from here, back corner edges which cannot be seen by the observer, hence you make it invisible, dotted. Okay, once you do, it is more or less complete. Now you show the axis. Once you show the axis, this problem gets completed. Okay, the problem is this. A hexagonal pyramid of size 25 and height 50 has one of its slant edges on HP with axis inclined at 45 degrees to VP. That is why we have undergone beta construction with only for one reason. The O1, what you have here, is not true length. But the problem given is axis should be inclined at 45 degrees to VP means it obviously it refers to true length of the axis. Okay, now this problem is over now. Now problem 17. Problem 17, like the previous ones, it is a problem of suspension. Problem of suspension. Here is a hexagonal pyramid of base size 25 and height 50 is hung on one of its corners of the base. Draw projections of this hexagonal pyramid. The top of the axis is inclined at 45 degrees to VP. Assume apex to be nearer to the observer. Okay. Now this is a problem of suspension. I'll tell you. See here, this is the hexagonal pyramid. As you know, these are the base edges. Okay, these are all 1, 2, 3, 4, 5, 6 base edges. 1, 2, 3, 4, 5, 6, 6 slant edges. Totally 12 edges. You know already. Now, what exactly you have to understand is in problem of suspension, we'll tie a thread to either this corner or this corner. Okay, this corner or this corner and hang it in the space. Okay, once you hang it in the space, this base comes nearer to the observer, apex comes down. Okay, now you see here. As usual, you do this. Hexagonal pyramid is the top view. 6 edges here, OA, OB, OC, OD, OE, OF. In that way, 12 edges. O1 is the axis and height is 50. 6 edges of the base here. 1 here, OB, OF merging edges. OC, OE slant edges merging. OD again slant edge. Okay. 1 slant edge here, 1 slant edge here, 2 here, 6 edges plus 6 edges, 12 edges. Now when it is problem of suspension, immediately on the axis O dash, O dash, locate the center of gravity. The center of gravity should be located 1/4 of its total height. If it is 50, you locate it at 12.5 mm. Okay. That is, since it is a solid, no? For an imaginary plane here, the weight below this portion is equal to weight above this portion. That is the significance of center of gravity. Now, let us say I tie a thread to this corner and hang it in the space. If I hang it in the space, what you should know is the line connecting the corner and the center of gravity will be perpendicular to HP. That means once you do this, D dash G dash will be perpendicular. That means move, copy, paste and rotate in such a way that D dash G dash is perpendicular to XY line. This entire thing you have copied here. Now, as usual, you get all the points to the other view and join the outer boundary of these points as the first step. First step is completed. Now, second step. You compare apex with the base. When you are looking from here, base is nearer to the observer, then the apex, immediately darken the base. Now you count the number of edges, 6 plus 2, 8 edges are over. Now you are left with 4 more edges. You see, you have to carefully observe what are the 4 more edges. 4 more slant edges. One is OD, one is OA, one is OF, one is OB. Okay. Now you see OD. OD, if you see, when you are looking from here, OD is the nearest edge which you can darken it. Okay. Then you are left with OF, OA, OB. Okay. When you are looking from the top, these are all back edges, that is back slant edges, OB, OA, OF and all that, which cannot be seen by the observer. As a result, these three things will be made invisible or dark dotted. OF, OA and OB. And as you see here, OA, which is invisible edge, when you are looking from the top, obviously OA cannot be seen. It is blocked by the solid. This edge, which is invisible, can be shown only between A and D because O to D you already have a visible edge. Always we prefer visible edge or invisible edge. In that way, don't show dark dotted between OD. It is because OD is a visible edge already darkened. Show invisible edge only between D and A. Okay. Once you do this, show the axis. Now the problem says the top view of the axis is inclined at 45 degrees to VP. The top view of the axis is inclined at 45 degrees to VP, and since the inclination we are not changing, the top view will not change. Inclination to HP remains same. The top view won't change. That is why we move, copy and rotate in such a way that the top view of the axis O1 is inclined at 45 degrees to VP. You could have rotated the other way also. Anything you take, but in this problem, they are clearly given apex should be nearer to the observer. That is why I rotated this way. O1, that is this top view of the axis is inclined at 45 degrees to VP. Now what you do is, once you have this top view done, you take the projectors to the front and as a first step, join the outer boundary of the points. Once you join the outer boundary of the points, you come to the next step. Next step is compare apex with the base. When you compare apex with the base, you see here, when you are looking from here, apex is nearer than the base. Immediately what you should know is, when apex is nearer than the base, complete base cannot be seen by the observer. The remaining edges of the base, you make it invisible. In that way, E dash F dash and F dash A dash, you make it invisible. Now you count the number of edges. 6 plus 2, 8 edges are over. Okay. Now you are left with O dash F dash, O dash D dash, O dash C dash, O dash B dash. Now you see here. O dash B dash, O dash C dash, O dash D dash, B, C, D. For an observer who is looking from here, all nearer corner, B, C, D are nearer corners. That is why O dash B dash, O dash C dash, O dash D dash, I'll darken it. Okay. And at the same time, O dash F dash, that is F is a back corner. For an observer who is looking from here, back corner edge cannot be seen. Hence, I'll make it dot dotted. Now, if you see here, I have made O dash B dash, O dash C dash, O dash D dash. Since they are nearer corner edges, I darkened it. O dash F dash, I have made it dot dotted. That is invisible. Okay, and finally show the axis and write the axis also thin line 0.13. In that way, you are completing the this suspension problem in all respect. As you are aware, at this stage, we have completed all sessions of projection of pyramids. That is, we have come to the end of session, say, and is the end of session 7. In fact, it is the end of pyramids. By reading sessions 1 to 7, by going through my sessions 1 to 7, you will be knowing completely the projection of pyramids. The all concepts will be known to you. Thanks for watching.